I am starting up the stream. Should be going right now. Hi everyone, I'm TigerHockey3, and today we're going to continue our work on the Python Deque double-ended queue, a data structure where you can add elements one by one, and add or remove from either end, because it's doubly linked. It's a double-ended queue, a Deque. So today, first thing we're going to do, and this is all available on GitHub in the link in the description, and previous segments are available on my channel if you want to see the video where I write these things or explain them, because I have one segment where I did stuff offline, and then the stream was just explaining things because it was messy. It was this method and this stuff. See how they're big and annoying? Yeah, it was annoying. It was like 3 hours of trying to play a shell game. Anyway, today, first thing we're going to do is we're going to extend a bug fix to where it should be, because what we added last time, one thing, was did I already do that? No, I don't think so. Extend left, extend. I do that somewhere, and that is here and there. If self is other. Okay. So this thing, if we have our Deque and we want to add it to itself, then we will look at the first item. Let's say we have 3 items. We're going to get the first one, and we're going to say, okay, now this Deque has a 4th item. We're going to get the second one, and we're going to say, now it has a 5th item. Then the 3rd one, this is the 6th item. Now by this point, instead of ending, the iterator will look at the Deque and see that there is a next element after this one that we thought was the last one, but now it isn't anymore. So it's going to say, okay, there's something after that, so I'm going to put it at the end, and it just keeps on doing that forever. It's bad. So this, since it calls extend, this functionality should be in extend. So I'm going to cut it out of here, because we have other, extend stuff. So I'm going to put it where it belongs, over here. There. And I think since this is a pure Python implementation, copying this same data structures might not be the best idea, so I'm just going to make it a tuple. That should be better. Cool. That's one change. Another change is, where can I find an example of this? This is our class name, Deque, and then I refer to it in here. What if I decide to change the name of the class to Deque, for example? Right? And then I would have a module Deque with a class Deque, and I would have, you would do import Deque, and then my data equals Deque.Deque instead. Maybe you do that. So instead of hard coding Deque here and in a few other places, we're gonna do this. We're going to we want the type of this object itself, and that will return this, this class. So we will keep looking through stuff. Should we change something here? I don't know, class.name, I don't know. Let's leave it like that. But this one, definitely. This one, great. So that's a teeny tiny bit slower, but it's okay. I don't care. I think that should be it for our small changes. Now we will add stuff. Rich comparison, meaning if one object of our class is less than or greater than or equal to or not equal or less than or equal or greater than or equal. So right now it is not implemented. So we're going to implement it. And I've checked with lists, tuples, strings, generators, etc. They're a little bit restrictive in that you can only compare one list to another list. You can't compare a list and a tuple, or a string and an iterator, or even an iterator of a list to an iterator of a tuple. It won't let you. So it has to be the same type. I don't know if our deck has to do that. I think I'm just gonna duck type it, meaning it will require a type that can work with it. And it's called duck typing because if it walks like a duck and quacks like a duck or something, then it is a duck or close enough to a duck. So instead of needing a deck, it can be a duck. Ha ha ha. Anyway, let's do that. And I'm all okay. How about just after these? Notice that I'm kind of putting off indexing and slicing because I don't want to do that yet. Okay. So if I wanted, I could do from functools import total ordering and then use the @totalOrdering decorator to just have a couple comparison methods, and then it would automatically call one or the other or both to, and invert them if necessary, negate if necessary, to determine other orderings. Like if you have one method that tells you whether one object is less than another, and you have another method that tells you whether one object is equal to another, then if you want to find out whether one object is less than or equal to another, you just take the two methods you've defined and say if this or that, and then you're done, right? But note this has to call two methods instead of just one, so it's basically twice as slow, worst case. So we're not going to do that. And all of our comparison methods are going to be very similar, going through each iterable and checking each item, whether it's, that comparison operator, whether that is true for each item and stuff. And so if we wanted, we could import operator, because operator has functions for each of these operators. That's what that module is for. I don't know if I've done a stream on that yet, but I might have. Possibly. There's a good chance. So each comparison method would just be like a little stub. Like the less than method would just call a core function that I could hide, like self._compare or something, and then I would pass it, this object and the other object that we want to compare, and also the operator that we want to use, like operator.lt, and then it would just, call that a bunch of times. But I did some testing with the timeout module, which I also think I have done a video about, and the actual literal comparison operators are about 4 times faster. than the operator module operators. So we're just gonna do that. Def data model. Okay, where am I going? Numeric types. No, we already did some of that. I add, etc. Where's the comparison types? Must be before. I'm currently looking in the Python documentation in the data model section. Here we are. And that is also linked to in the description. Yes, it's the second link in the description. The Python data model documentation has all of these things. Okay. Less than. Great. Less equal. Equal. Not equal. Greater than. And greater than or equal to. Fantastic. I was going to say great, but you know, great or equal? Huh. Anyway, so less than. First thing we're going to do is check whether the other object is a valid thing to compare a sequence with. Like something that we can iterate over and that has a length, right? If not, so we're going to say if this other thing isn't valid, then we're going to return not implemented. So if not, and what it has to be able to do is go through, iterate over the other object, and the other object has to have a length. In theory, if we got like a generator or something, then we could go through everything and then checking whether it has a length. Instead of doing that, because generators don't have a length, they're lazy objects, we could just try to get next elements of it a bunch of times, but that's messy and we're not going to do it. So, and for this we're going to use the has attribute, HASATTR built-in function. Has attribute, and it's going to be other. So it's checking the other object for an attribute that is iter, and that means, in theory, it means we should be able to iterate over it. If you want, you could return an iterator from that method that's just wrong, but how is that useful? I don't know. So if you're using a module where people have magic methods that return things that are wrong, like you could define a len method that instead of returning some useful length of the object or not implemented if it didn't make sense, it could return a word like hello. I think. Can it? Because sometimes these require other things. It might need an integer. It could always return 0 or something. So, not guaranteed to be useful. The iter could return an iterator of some other arbitrary object. I don't know. So if you are relying on this to work, then it will require that the thing you're comparing it to be honest. Has to have an iter and has attribute other len. I need another of those. Great. So it needs this and that, and if it doesn't, not implemented. Not implemented. Okay. Great. And that's going to be in all of our comparison methods. And now we're going to the way lexicographic sorting works, which is alphabetical order, basically, but it can be used on things that aren't alphabetical, like a tuple of numbers or something. It checks each corresponding element, so it checks the first element of each thing that you're looking at, and does that comparison operation. And if it's true, then it's still true, and it goes on to the next item in both objects and does the comparison operation. And if at one point it does that and it's false, then the entire method should return false. And if it gets to the end of the zip, remember, zip truncates the longer object. So if it gets to the end of the shortest one, let's say we have an object this long and an object this long, it's going to go through both, and if they're the same up to there, then we're going to look at the length of each object. So if they're the same, let's say we're comparing the strings ABC and ABCD. So let's have ABC over here and ABCD over there. Which one is after? Which one is larger or greater? We have ABC, they're the same, and we have exhausted this one, but we haven't come to any determination. So we're going to check if this one is longer than this one, and it is. So the length is bigger, so the whole object is bigger at that point. So for AB in zip self other, if I'll just do the inverse of this. The inverse of less than is greater than or equal to. If A greater than or equal to B, return false. If length of self is greater than or equal to len of other, return false. Return true. That should be it. Let's think of the strings ABC and ABA. So let's say we're checking whether ABA is less than ABC, which it is. So first A is A and B is A, right? ABA less than ABC, which is going to be true. So is A greater than or equal to B? The letter A is not greater than or equal to... Oh, no. I already see a problem. This is wrong, isn't it? If it's... I did something wrong. So we compare both. If they're the same, we continue. Okay. Maybe it's just greater. Yeah. Because if A is greater than B, we already know that it's not the case. Then it can't be smaller than the other one. Like if we had B here and A there, then we would know it's larger already. But if they're equal, then we just have to keep checking. So if A is too big, if A is bigger than B, return false. A is not bigger than this other A, so we go to the next one. B is not bigger than B. So we go to the next one. A is not bigger than C. It's still smaller. So we go to the next one, and there's nothing more to do. This should also be greater. If this one is longer, then I have something incorrect here. What if we had AAA and BBB? Something's wrong here. Maybe I should have put this off and just done the indexing, huh? Okay. I need an algorithm for sorting. How do I find if one object is less than the other? If something is greater, this is awkward. I thought I had this algorithm figured out, but this will not work. False. If they're always when do I want to check the length? If they're the same up to that point? Only if they are the same. Let's write equals first. Return all A is equal to B for A, B in the self other, and len self equal to len other. That should be it. All the elements are the same, and they have the same length. Then they are equivalent. Actually, that would have to be the... we can't actually do that because we're looking for the type, huh? Because a list isn't equal to a tuple. That's false. Maybe that's why, because we want to check equality is going to need the same object. Should less than or equal to be less strict? I don't know. Maybe we'll just, maybe we'll change this. Because this doesn't make sense here. We could have a Deque be equal to a tuple, and that wouldn't make sense. I think if someone wanted, they could already just do this on their own. So I'm going to actually specify is instance other type self. let's just go with that instead. Because I think it would be weird for equal and not equal to check the type, but the other things not to check the type. Oh well. Forgot about equal. Not self equal to other. There. That should work. Okay. Now, less equal, greater than, greater equal. How do I do that? Let's think of some things to compare. Okay. So I think we only check the length if the rest is equal. Would that mean 2 checks? That'd be a little weird. A is less than B, so immediately we would know that's true. A less than B, return true. Let's do that. So if we're comparing them and one is actually less than, because A is already less than B, so we already know that we don't have to check anything else. Return true. How about this? If A more than B, return false. Because we have B and A, and we already know that B isn't less than A, so we don't have to check the rest. Okay, so this leaves equals as ambiguous. And then we get to if one is longer, because if this loop completes and nothing happens, then it means all the elements were equal to each other. In which case we want to check the length. Yes, okay. Great. That's pretty good. I'm happy with that. Okay, how about less than or equal? I think we'll need these things. Only we're going to add this duty. Okay. Less than or equal. I think we can actually, we will make this the greater than already. Less than. Switch that around. Okay. actually, this can just be return this length is smaller than that length. Great. Then we have this, and we switch it around there. Great. Now how about less than or equal? So we've got A is less than or equal to B. So if it's greater, it's false. Let's do some massive copy pasting. Okay. If it's greater, then we know it's false. But if it's smaller or equal, then it's fine. And so this is a stop condition, basically. Looks good, looks good. Oh, definitely not true. Actually, this A less than A, and A. So this would mean we get through this loop and nothing happens. So then we have to check the length. Length should be less than or equal. Okay. Less equal, greater than equal. Okay. So each item should be greater than or equal to, so if it's less, then it's false. And greater than equal to. Alright. Great. That's good. That's good. For this one, by the way, I had to do not one equals the other, rather than just return self not equal to other, because that would call this method. That's what we're doing, so we can't define it in terms of how we get to it. That would not work. Okay. Let's take that out. Has to be strictly less than, so if it is already, if we look at some item and it's less, then we know the whole thing is less, it's smaller, and we can return true immediately. And if it's bigger, we have to return false immediately. But if it's the same, then we have to keep going and look at everything. If we've already looked at everything, then we're looking for the shorter one, is the smaller one. Less or equal. If it's greater, we already know it's wrong. But if they're all less than or equal to, then we will check the length, and the length should be less than or equal to. Is that right? Hang on. I think the less than and greater than are correct. Something that is less than or equal. So it's true that it's equal, and here it's less. Two of them. Something like that. And how about where this is longer? A less than or equal to A less than or equal to AB. I think these are all true. I'm pretty sure. A is not less than or equal to A. Okay, right, because A and A are the same, and this length is longer. Okay, so in what case do we want to check the length? If we have one item is less than or equal to that, this is less than or equal to that, it's true, it's less than or equal. If the item in self is greater than the item in other, then we immediately know it's false. I think I have something wrong here. What if they're all less? Then it's fine. What if we had a string that's lots of stuff less than or equal to think, huh? We're going through it, and if the one that should be less than or equal to is actually greater, then we're done. Then we're done. If we get to the end and nothing violated it, then it should be fine. But if they were all the same, I think we need to do something similar. I think we need this. If one is just smaller than the other, then we know it's less than or equal to. And we don't need to check the length. I think we need this part. And similarly, greater than or greater than or equal to needs this. They need that. So if we get to the end without returning the end of our loop, then that would mean that everything was the same, and then we just check the length. Okay. So we're comparing similar items. If we're comparing less than and it is less than, then we don't need to check the rest. If it's too big, then we don't need to check the rest. But the exceptional case where we have to check the whole thing and then just look at the length is if they're equal. And so we don't have a return for if they're equal. And then we do less than, true, false, less than or equal. Greater than. If it is greater, then we already know. If it's too small, false. If they're the same, then we have to check the length. Greater than equal to. Great. That should be that. 40 minutes. We've done those things. We've done comparison. We should test this for real. about let's do the following. Let's say there's the letter Y over there instead of D. So 1 is smaller than 2, should be equal to itself. Okay. This is 1 and 2, and we're going to change the D to a Y here. How will we write this compactly? I don't know. If D1 less than D2 not equals E1 less than E2, print less than, less equal, equal, not equal, greater, greater, equal. Greater, greater, and greater. Less equal, less equal, less equal, greater than or equal. Let's do greater first, actually. It doesn't particularly matter, actually. Less, more, less equal, yeah, more equal, because I already did greater than above. Greater than equal, equal, not equal, equal, and not equal, and equal, and not equal. Great. Fine. Let's test that. No failure. Now let's make some things that are a different length. D1 plus L, I don't know, it doesn't matter. Now D3 will now be equivalent to D1, except it'll be longer, so we'll have something else at the end. E1 plus, yeah, no, not this. Plus collections.deque with L. Okay. Now let's just call it 3. This would have been a lot easier to do by just changing. You know what I could have done? Do you know what I could have done? this. There. And also, of course, change that back. So now they are identical in terms of zip, but different lengths. Perfect. I like when it's perfect. That's good. So those are, that's our testing that we're going to do for our comparison methods. It's kind of a lot. From 238 all the way down to 279. It's like 40 lines of stuff. We would have had a much shorter module if we used total ordering, but it would be slower. And we're trying to optimize it because collections.deque is written in C. It's very fast. This is not written in C. It's pretty slow. The reverse is superior. Because reverse for this just looks at it in the other direction instead of doing any reversing. So that's cool. Do we have time for more? Maybe indexing and not slicing yet? Let's put it near neighbors because it's going to use that. Oh, there's get item and set item. Shouldn't be too bad. Get item, set item, and missing. But I think the double underscore missing is the following methods only apply when an instance of the class containing the method appears in an owner class. I don't know what that is. No thanks, I don't need that. Descriptors, slots, creation, meta classes, blah blah blah. Call is something that's cool, but we're not going to do it. Okay. Note, slicing is done exclusively with the following three methods of get item, missing, and set item. Missing called by dict.getItem to implement self key with brackets for dict subclasses when key is not in the dictionary. This is not a dictionary subclass, so we don't need missing. Get item and set item. Get item and set item. Easy, right? Totally easy. Get item. Element. This is equivalent to this is the get item would be called when we do my deck, 3 or whatever. And this would be called when we do my deck 3 equals 8 or something. So here we have I, and here we have I and element. That's what we need to implement. And these also handle slicing, so we'll have to check whether I is an integer or a slice object, meaning my deck, this is a slice object now, which is equivalent to my deck slice. It's a built-in function. 3, none, and none. 1 is what that gets translated into when it calls get item. 3, none, and none is what that gets translated into when it calls get item. 3, none, and none is what that gets translated into when it calls get item. 3, none, and none is what that gets translated into when it calls get item. 3, none, and none is what that gets translated into when it calls get item. 3, none, and none is what that gets translated into when it calls get item. 3, none, and none is what that gets translated into when it calls get item. 3, none, and none is what that gets translated into when it calls get item. 3, none, and none is what that gets translated into when it calls get item. 3, none, and none is what that gets translated into when it calls get item. 3, none, and none is what that gets translated into when it calls get item. 3, none, and none is what that gets translated into when it calls get item. 3, none, and none is what that gets translated into when it calls get item. 3, none, and none is what that gets translated into when it calls get item. 3, none, and none is what that gets translated into when it calls get maybe we can implement these for just integer for now, and the next section, the next stream will be slicing, because that's a whole bunch of stuff with start and stop and stride and going backwards, etc. Whole bunch of nonsense. So if not is instance I int, or not is instance, no, yeah we do, is instance I slice, right? Is how it works. I can get rid of this. None slice. We just, yeah, true. Okay. So what kind of error do we get? Type error. Let me show you what I'm looking at. This thing. So we have a string that we are attempting to index with an empty string. It has to be an integer. So it says string indices must be integers. But they don't have to be an integer, they can be a slice object. And then we give it a bad slice object. And slice indices must be integers or none or have an index method. Maybe this is called automatically in slice. Okay, that's not really what I expected. So it doesn't complain there. That's annoying. So if it's some kind of slice object, then I have to check all the arguments. Because you can have a slice that doesn't make sense. I don't know why. That should probably be checked internally, I think. Let's invert this and just say if it's an int, if it's a slice, other stuff, and then okay, first let's say if it's not a slice, then it has to be an integer. If it's not a slice, if it's not an integer, raise type error. Deque indices. Actually, what does the deque say? D something. Sequence index must be integer, not type of whatever. Sequence indices must be, and I know that it doesn't support slicing at all. Must be integer, not string, not slice. Doesn't handle it. It just doesn't. Type error. Let's say deque. Deque indices, index, slice indices, sequence index, list indices. And what if we give it a bad slice? That's some really complicated error checking that we're gonna have to do. Ugh. Can't just be a generic doesn't work. Has to be is it not a slice? Okay, then it has to be an int. Is it a slice? Then everything has to be this stuff. You know what? The standard Deque doesn't even handle slicing at all. So know what we're gonna do? Just not this or that. There. Must be integers or slices, not type of I. Repro type of I. Fine. Okay. Let's put this in here too. Great. Has to be a slice. There's other stuff that can go wrong, of course. If it's an integer, then we do a bunch of integer stuff. If it's a slice, then we do yet other stuff. I don't know if we can flatten this. It's going to have to be a little bit nested. Okay. Maybe I shouldn't have started this. I thought it would be easy, but no, because of all the error checking. So I just realized right now I forgot to turn off the fan. Hopefully it's not very loud. I can turn it off now. I'm looking at audio levels and it doesn't look like it made much difference. But hopefully it's okay. No one's currently watching this stream, so if you watch it when it's archived, you can blame people who didn't watch and would have said, hey, you left the fan on, there's a noise, and then I would turn it off. Anyway, if it's an integer, if not self.quantity less than or negative quantity should have to be less than or equal to I, which should be less than self.quantity. Raise raise what? Oh, this is my lovely error message that you couldn't see. But I'm doing more stuff here. Index out of range. Okay. List assignment index out of range. That's going to be in set item. Raise index error. Deque index out of range. Great. So if they give a good index and it's an integer, after this we know it's an integer slice, after this we know it's definitely an int, and it's within range. Okay, great. Return self dot neighbors I 1 dot element. That should work. For I in range, we're gonna get rid of these. For I in range negative len d to positive len d, which will not include the length. Actually, let's do that after. If di not equal to ei, print I di ei. Great. D len d. This should make an error. Okay. Let's see what happens. I want to run stuff. Expected unindented block. Oh, sorry, I have. Where's the, what's it? Where am I? Set item. I didn't take care of this part. My bad. You can't do that. Okay. All it does is print an error, which I think is what we wanted. We said do this. If they're not the same, then print a thing. It didn't. Trace back. Deque index out of range. Deque index out of range. Cool. Maybe something more descriptive that mentions the acceptable things. Let's make it a format string. Deque index I out of range. This to that, which is negative self dot quantity to positive self dot quantity minus 1. Cool. Let's do that. Oh, I missed it. What did I do wrong? Expecting a... Oh, oops. I didn't hold shift hard enough. Deque index 11 out of range negative 11 to 10. Cool. So this says you gave it an index of 11, but 10 was the highest you could go. So that's useful, I think. You don't have to do any print debugging if you're just trying to find out what index caused the problem and what the size of the deck was at the point that the problem occurred, because it tells you right there. I think that is Good. Makes me happy. Okay. Set item. Let's handle it for ints. So here, assignment index. So instead of returning this, we will say numbers 1 dot element equals element. We can do that, right? Okay. Yes. The regular deck does have a set item that works like this. This looks like something that I might want to delegate. Yeah, this is going to be a helper function somewhere, because these are all basically the same. The only difference is whether we return it or assign to it. About we're going to do DI EI equals EI DI. If a tuple out of D is not equal to a tuple out of E, then print the things. Let's see what happens. Nothing, and the error we wanted. Deque assignment index 11 out of range, -11 to 10. Neat. So we kept doing stuff, and it always works. And it says assignment index out of range. Cool. How about, let's do the following instead. Print D. D2 equals 3. Print D again. I want to see stuff happening. D, okay, 0, 1, 2, instead of C, it's going to be 3. It works. Cool. So, that's pretty good. We have not yet implemented slice operations. It says it has to be an int or a slice, and it gives a generic error message. If you give it something it isn't a slice, but isn't an int either, it doesn't say it has to be an integer index. And then if you give it a slice that's bad, it doesn't give a specific error message about that. It just says it has to be an integer or a slice. Let's say that they are int none slices, not strings. Must be integers or int/none slices, not whatever type you gave it. Although, if you did give it a slice, this would be bad. Actually, this is only if it's not an int or a slice. And then it says it has to be an integer or a slice with integers and none. And then when we do the slice behavior, we will say, you know, then we'll check all the parts of the slice, and I think it's like start, stop, step. Let's check. Can we do this? Yeah. Indices start, step, and stop. So start is where it starts, stop is where it stops, non-inclusive, and step is the step or stride value. So if you have a step of 2, it means every other element. And I think the slicing will, instead of optimizing for runtime, basically, it's just going to go in the direction that you want it to go and start where it has to. So if you have a deck like this and you want a slice just in the beginning but backwards, it's going to go backwards until the start point that you want and then continue on. And that's it. Instead of, you know, we're gonna get neighbors and then we're gonna go here and then we'd have, you know, if forward or reverse, self.next. No. We're just gonna iterate through in the step direction that you choose and eventually arrive at the element we want. Yeah. That's not written in stone. I may decide that it'll be sufficiently easy to do that. Actually, slice assignment is kind of... Is that different? No. Instead of adding it to a deck, because the slice creates a deck. If you just reference a slice of something, it creates another sequence of that type with the elements you wanted. Whereas assignment is a little weird. There's other stuff. For now, it's just integers, and I'm not 100% sure, but I think we have matched the collections.deque functionality in total. We have append and append left. We can clear, copy. We can get the count. Extend and extend left. Index with X start and stop. Insert. Pop, pop left. Remove, and our remove is fancier because we can remove any number of items instead of while element in deque.remove element. That would, you know, that's a Schlemiel the Painter algorithm where we're going to have our deck and then we're going to go through it and say, aha, this is something we want to remove that, and then it's smaller. And then go through it again. Later we have something else to remove and smaller, and then at the end it's smaller. That's going through the deck a whole bunch each time. You don't want that. That's an O of n squared algorithm, whereas ours would be O of n. Just look through it once and keep taking out the things you want to take out. Remove reverse. Our reverse is O of 1. Rotate. Our rotate is O of n, but hopefully a smaller n than might otherwise be possible, instead of doing some appends and pop lefts or pops and append lefts to just manually like rotate the thing around. It finds where it has to split the thing and then just cuts it and switches it around. Probably faster, because it's just iterating through instead of creating a whole bunch of nodes and stuff. Maxlen, we have that. Deck support iteration, yes. Pickling, yes. Len, yeah. Reversed, yeah. Copy.copy, copy.deep copy. Oh, is there a copy thing? No. There is no copy special method. I think it just works. Copy.copy, copy.geek copy. Membership testing within, that's contained, we've done that. Subscript references such as the square bracket -1, we have that, we just did that. Index access is O of 1 at both ends, but still to O of n in the middle. That's true for ours as well, because getNeighbor tries to go from the closer edge. For fast random access, use this instead. Starting in version 3.5, Deque support add, mul, and imul. We added those last time. A couple of those last time. Also iadd, our supports. E plus equal okay, there supports iadd also. And I think that's it for the basic stuff, but ours is going to support slicing. That's for sure. I want that. What else do we have in the data model? I'm basically looking for special methods and thinking, should ours support that? Do I want that? Del, etc. Rich comparison, we did that today. Hash, no, I don't think so. It's not going to be hashable. Does it have to return not implemented if it doesn't count? Because this is a mutable object, basically. If it does not define an equal method, it should not define a hash operation either. If it defines equals but not hash, its instances will not be usable as items in hashable collections. Good. I don't want it to be. If a class defines mutable objects and implements an equal method, it should not implement hash. Since the implementation of hashable collections requires that a key's hash value is immutable, if the object's hash value changes, it will be in the wrong hash bucket. We can talk about that later if anyone cares. But it's why you can only use immutable objects for keys. Bool we have. Get attribute. No, we don't need that. Nope, don't need that, don't need that. Super bindings, don't need that. Slots, I don't think I care. Meta classes. We're not doing any of that. Call, there's a double underscore call method that happens when you have an instance of your class and you call it like it's a function. That's pretty neat, but we're not doing it because I don't know what it would do. Doesn't make sense to me. It's like you can have your Deque do something. What are they gonna do? I don't know. Or send it something. Again, I don't know. Like I could just bind it to append or something for a shortcut, but I think that would be arbitrary and confusing. So we're not going to do that. Len, I got that length hint, not necessary. Get item, set item, we're doing that. Del item, oh, called to implement deletion of self.key. Same note as for get item. So this is to remove something at a certain index. So yeah. Okay, del item as well. So that'll be for next time. I don't know if we can do it in the regular deck. Del D0. Yep, that works. Okay, so we are not yet at that point. Let's see what happens here. Del D0. Save. What are we doing? What are we looking at? I need this. I don't need that. I need this. I want that. Attribute error, del item, because we haven't done it yet. So that'll be a thing that we have to do. Yeah. And this will probably be a short method that calls a longer, more general one, just like we did with remove and replace. Because the only difference between remove and replace is if we take out the node or change the element. Everything else was the same about them. Remove, replace, this big thing, then remove and replace are very short. So we'll have something similar with the set item, get item, and del item. So our deck is not quite yet equivalent to the built-in del item we don't have. We have reversed, we have contains, we have add, I don't know, mod, div mod, pow, shift, and XOR, or no. Just no. radd, no. No, I don't want any of those. iadd and imul, we did that. There's no sub, there's no matrix multiplication for this. Division, you can't divide a, no. Is there a positive version of a sequence and a negative sequence and an absolute value of a sequence? An inversion of a sequence? No, I don't think so. In float round, no. Index operator dot index. Whenever Python needs to losslessly convert the numeric object to an integer object. I see. No. With for context managers, coroutines, no. Just no. Asynchronous iterators, no. Okay, so the only thing we have left for feature completeness as far as the collections.deque and standard library is concerned is the ability to remove an item by index. Okay. And that will be basically do most of this stuff, but only for an int. Can you delete a slice? Well, probably not with a deck. But you can with lists. So del item will have to handle integer indices and slice indices, so that's great. But it's going to do something similar, but instead of returning the elements or reassigning them, it's going to delete those nodes. Similar to remove. It'll do this stuff, basically. This exactly, and that. And of course this thing. No, not this thing. This, I don't know if it needs the counter. I don't know. Anyway, that's some stuff to do next time. Slicing. Del item. slicing for access, assignments, and deletion. We did those. Okay. Alright. That's it for today. But next time we will have more stuff, including slicing and del item, and I don't know what else, honestly. Ooh. That might be it. But we will see. We will see. So, once again, this is on GitHub, and I will push this version after the stream is done, and then you'll be able to see it in the small scripts repository that is linked in the description. And previous segments are on my channel. Remember to like, comment, subscribe, and thanks for watching, and have a good one.